Hello everyone. So myself Dr. S. Arivalagan, Assistant Professor, Center for Applied Geology from Gandhigram Rural Institute, Gandhigram. Today I am going to discuss about the physical properties of minerals. So we know that the mineral is a naturally occurring inorganic solid with a definite chemical composition and uniform atomic structures. Here we are going to discuss about the two type of minerals such as the rock forming minerals as well as in the ore forming minerals. Here in the rock forming minerals will be discussed about it will be found in the rocks of the earth crust. The ore forming minerals will be found in the and will be having the economic value and which do not occur in the abundance in the rocks. So about the physical properties of the minerals, we are going to discuss about the following properties such as the color, streak, luster, hardness, fracture, cleavage and specific gravity, crystal structure and magnetism. About the color is the most obvious but least dependable properties of the minerals. Some minerals always have the same color such as the gold. Other minerals have a wide variety of colors such as calcite, which can be pink, orange, blue, green, red, brown, white or clear. Sometimes other elements can cause a change in the color. For example, if you take the pure quartz, it will be clear in nature, but if it is the iron was present in the quartz while forming, the color of the quartz will be purple. The purple color quartz will be called as a amethyst. Some minerals will have a different color of viewed under the ultraviolet light. These minerals are said to be fluorescent. Here you could able to see that there are two type of quartz such as the pure quartz as well as in the amethyst too. The next, the powder of the mineral will be called as a streak. It is the most consistent and the label than the body color of the mineral. The streak is obtained by the rubbing the mineral against the unglassed porcelain plate called as a streak plate. For example, the hematite, which appears almost black in color, gives a red color streak, which will be the identifiable character for the hematite. Next, we are going to discuss about the luster. Luster is the way the surface of the substance reflects light and is used to describe how mineral looks in the visible light. It is impossible to identify the minerals that have the same luster on this characteristic alone. Here we are going to discuss about the metallic luster, vitreous, adamantine, silky, pearly and dull lusters. If you take the metallic luster, it will be having the opaque and reflects like metal elements exhibited. If you call about the vitreous luster, it will be having a glassy in nature and applies to about more than 70% of the minerals. If you discuss about the adamantine luster, it will be called as a brilliant or diamond-like light and it will be having the high shine. If you call it a silky luster, it will be having the reflect like silk cloths. And if you call about the pearly luster, it will be similar to the white shirt button. And if you call about the dull luster, it will be having the poor reflectors. And the minerals will have the rough. Next, we are going to discuss about the cleavage and the fracture properties. The cleavage describes how the crystal breaks when subject to stress on the particular plane. Whereas the fracture is a description of the way a mineral tends to break. It is different from the cleavage and the parting, which are generally clean flat breaks along the specific directions. The fracture is a characteristic way a mineral breaks. The difference between the cleavage and the fracture, the cleavage is the break of the crystal face when the crystal face is formed whereas the fracture is clipping in of the minerals. Next, we are going to discuss about the habit of the mineral. The habit of the minerals may be defined as the size and the shape of the crystals and the structure or form shown by the crystal aggregates and cryptocrystalline masses. If we call about the acicular habit, the mineral showing needle-like structures or else in the crystals, for example, natrolite. If we call about the fibrous habit, the minerals showing the aggregate of the long, thin fibers, example, asbestos and the satin spar. If we call about the bladed in habit, so it will be having the minerals will be having the elongated crystals, example tourmaline and quartz. If we call about the tabular habit, the minerals showing the broad flat surfaces, example feldspar. The granular habit discuss about the aggregate of the equidimensional grains such as the chromite. And next and last, the batroidal habit discuss about that the aggregate of the rounded masses resembling bunch of grapes. Example, the chalcedony. Here the figures are describing about the various type of the habits. The next we are going to discuss about the hardness of the minerals. So this is defined by the mineralogists named Frederick and Mohs in 1822. So here it has been classified as the 10 classes from the 1 to 10. The 10 is denoted for the diamond, and the corundum is denoted for the 9, topaz is denoted for the 8, and the quartz will be having the hardness of 7, orthoclase will be having the hardness of 6, and apatite will be having the hardness of 5, and the fluorite having the hardness of 4, and the calcite having the hardness of 3, gypsum has 2, and the talc will be the least hardness such as the 1. The next is we are going to discuss about the physical property called as a specific gravity. The specific gravity will be measured by the weight of the substances divided by the weight of an equal volume of water. Here the formula is given to measure the specific gravity equal to weight of the material in air and divided by weight in air minus the weight in the water. So based on this formula we could able to measure the specific gravity. Next we are going to discuss about the physical characteristic such as the specific gravity of some type of the minerals. Here it will be described as a framework silicates such as the quartz and feldspar will be having the hardness of the specific gravity of the 2.6 to 2.7, and mica amphibold will be having the specific gravity about 2.8 to 3.2. The pyroxene will be having the 3.2 to 3.6, and the olivine will be having the specific gravity of 3.3 to 4.4, and the hardness will be having the specific gravity of 3.5 to 4.4, and the sphalerite will be having the specific gravity of 4. Chalcopyrite will be having the specific gravity of the 4.2, and the native gold will be having the specific gravity of the 12.4. Then next we are going to discuss about the physical properties of important rock forming minerals. Here we are going to discuss about the quartz. The color of the quartz will be clear to white in nature. Mostly it will be having the white color streaks and having the vitreous luster. Mostly the quartz will be having the absence of cleavage and having the conchoidal fracture. The hardness of the quartz is around 7. The specific gravity of the quartz is 2.65 to 2.66. The quartz is used as a gemstone, mortar, and used to make it as a scientific apparatus. It will be available in the igneous, metamorphic, and sedimentary rocks. The next we are going to discuss about the physical properties of the feldspar. The color of the feldspar will be vary based on the impurities such as the white, grey, pink, and green. Will be having the vitreous luster. The cleavage will be present, and they will be having the two-direction cleavage will also be present. It will be having the conchoidal fracture and generally tabular in habit. Hardness of the feldspar is around 7. The specific gravity of the feldspar is 2.55 to 2.63. The feldspar used in the ceramic industry and ornamental industries. It will also be available in the igneous, metamorphic, and the clastic sedimentary rocks. Next we are going to discuss about the physical properties of the mica. The mica will be mostly colorless. Sometimes it will be pale shades of green and brown in color. The luster is pearly and silky, will be having the perfect cleavage, and about the habit, it will be mostly tabular in nature. Sometimes it will be in the foliated in nature. The hardnesses of the mica will be 2 to 2.5, and the specific gravity of the mica is 2.76 to 2.88. The mica is used in the electrical and the fireproofing and the duplicate and wallpaper industries. It is available in the metamorphic, igneous, and sometimes it will be available in the accessories of the sedimentary rocks. Next we are going to discuss about the physical properties of the amphibold group minerals. The color of the amphibold group minerals will be having the white, grey, and green. Will be having the vitreous and silky luster. It will be having the perfect cleavage. About the habit, it will be generally tabular, sometimes bladed, and sometimes fibrous in nature. The hardness of the amphibold group of minerals will be having the 5 to 6, and the specific gravity will be around 3 to 3.3. Some forms of amphibold groups are used as asbestos. It is mostly available in the igneous and metamorphic rocks. So next we are going to discuss about the physical properties of the pyroxenes. So the pyroxene will be mostly classified as orthopyroxene and clinopyroxene based on the compositions and their physical properties. The color of the pyroxene will be grayish or yellowish or greenish in nature. It will be having the vitreous luster, will be having the imperfect cleavage, and generally massive and lamellar habit. The The hardness of the pyroxene will be around 5 to 6. The specific gravity will be 3.2 to 3.3. The pyroxene used as a specimens and sometimes it is also used as a gemstones. So mostly it will be available in the igneous and metamorphic rocks. The next we are going to discuss about the physical properties of the olivine. The color of the olivine will be mostly pale greenish and also called as a olive green. It will be having the vitreous luster, having the conchoidal fracture, granular habit. The hardness of the olivine will be around 6.5 to 7. The specific gravity will be around 2.2 to 4.3. The olivine is mostly used as a specimen. Sometimes it is also used as a gemstones. Mostly olivine will be available in the igneous rocks. The next we are going to discuss about the physical properties of the garnet. The color of the garnet will be brown or yellow. It will be having the vitreous to resinous in luster. Mostly the cleavage will be absent for the garnet. Will be having the uneven fracture, granular habit. The hardness of the garnet will be 6.5 to 7.5. The specific gravity will be around 3.5 to 4.3. The garnets are mostly used in the gemstone and also used as abrasive stones. The garnet will be available in the metamorphic rocks. The next we are going to discuss about the physical properties of the epidot. The color of the epidot will be pale greenish and yellowish in nature. Will be having the vitreous luster. Will be having the perfect cleavage and uneven fracture. The hardness of the epidot is around 7. The habit of the epidot is fibrous, sometimes massive and prismatic. It is used as an industrial mineral and also used as a gemstones. Mostly available in the metabasalts and also in the marbles. The next we are going to discuss about the physical properties of the beryl. The color of the beryl will be around pale greenish or yellow in nature. It will be having the vitreous luster and the perfect cleavage. The conchoidal fracture, the hardness of the beryl is around 7. It will be having the fibrous in habit. The specific gravity of the beryl is 2.6 to 2.7. It is used in the gemstones and the mineral specimens and the source of the beryl. So today we have learned about some specific rock forming minerals and their physical properties. Thank you.